Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Good morning. Today we are going to examine forest fire management with a focus on prevention and controlled burning strategies. I will describe the rationale behind prescribed fire, the techniques used to reduce fuel loads, and how prevention policies and community measures complement burning programs. First, why manage fire at all? Fire is a natural process in many forest ecosystems. It can reduce accumulated fuels and promote species regeneration. However, when fuel builds up due to long-term suppression and climate-driven drying, fires become more intense and destructive. Forest fire management aims to reduce that risk while maintaining ecological function. Prescribed burning or controlled burning is the deliberate use of fire under predefined conditions. Objectives include reducing surface fuels, recycling nutrients, and creating a patchwork or mosaic of burn intensities that interrupt large-scale fire spread. A successful prescribed burn requires a burn plan, a qualified burn boss, ignition tactics, and an approved weather window. Ignition tactics vary. We use drip torches for hand ignitions to create backfires and strip head fires. For large or inaccessible areas, we may use aerial ignition with incendiary spheres dropped from helicopters. Pile burning is used where material is concentrated after mechanical thinning. Each tactic has trade-offs in control, cost, and smoke production. Timing is crucial. The burn window depends on fuel moisture, wind, temperature, and atmospheric stability. Low-intensity surface burns are planned when surface fuel moisture is moderate and winds are predictable. The burn plan always includes a contingency for escape, mop-up procedures, and post-burn monitoring to ensure objectives are met. Smoke management is another essential element. We always include a smoke management plan to protect public health and to comply with air quality regulations. This plan specifies acceptable smoke dispersal conditions and may limit the daily acreage burned to avoid exposing vulnerable communities to smoke. Prevention strategies extend beyond burns. Mechanical thinning, creating fuel breaks, community defensible space, and building codes all reduce the probability of structure loss. An effective program combines treatments on the landscape with education and early detection systems, such as lookout towers, automatic sensors, and satellite monitoring. Case studies are instructive. In parts of Australia, managers use mosaic burning to reduce contiguous fuel while conserving habitat heterogeneity. In Western North America, decades of fire suppression led to heavy fuel accumulation. After the large fires of the 1980s, forest agencies began to reintroduce prescribed fire under careful protocols to restore more natural fire intervals. Risk assessment tools and fire behavior models support decision-making. Models estimate rate of spread and flame height for given fuel types and weather scenarios. Managers use these outputs to decide buffer distances from infrastructure and to plan suppression resources on standby during burns. Adaptive management is key. Agencies monitor burn outcomes, measure fuel reduction, and track vegetation response. If smoke impacts or escaped fires occur, policies are revised. Long-term monitoring can show benefits such as increased seedling recruitment or reduced canopy mortality in treated stands. Finally, social and legal contexts shape practice. Permits, public notification, interagency coordination, and liability rules determine when and how prescribed burns are conducted. Engaging local communities builds trust and helps managers schedule burns during acceptable times for visibility and health reasons. In summary, forest fire management integrates prevention measures and controlled burning to reduce hazardous fuels, protect communities, and maintain ecosystem processes. Effective programs are planned, science-based, and responsive to changing climate and land use patterns. That concludes the lecture, and I will take questions.
Listen again to part of the lecture, then answer the question.
We always include a smoke management plan to protect public health and to comply with air quality regulations.
This concludes the listening section. For more TOEFL practice tests and study materials, visit Spinta.org.